Okay, students, now we are starting with the very beginning, very important chapter of your second year, 12th class. Okay, so that is chemical kinetics. This also we will be doing from the basic and discussing all questions related to the topic separately. Okay, so let us start with the chemical kinetics. We will start from the basic and leave up to the advanced level. Okay, so stay with me and learn with fun. Okay, so chemical kinetics. People sometimes they feel confused. Is it physics or chemistry? Okay, so chemical kinetics is a chemistry only, but kinetics we are studying for the chemical reactions. We are going to study the chemical reactions kinetics, not anything else. Okay, so kinetics of the chemical reactions is called as a chemical kinetics. Now the difference in physics kinetics and here, there you will measure the displacement, but here you if you measure that the same procedure here, you will get always zero, because neither reactant are going to move nor product are going to move. So displacement will be zero. So chemical kinetics is going to be zero. So the word is same, but the utilization of the word is different. Okay. So kinetics means moving. Here, moving means changing from reactant to product. How many things changed, moved from reactant towards the product? That is only we study here. In chemical kinetics, the rate of change of reactant into product. The rate of change of reactant into product is called as a speed of the reaction. Here, it is not the distance traveled by a reactant, distance traveled by a product. Here, distance is not matter. Concentration matters. Okay. So that branch, there is a separate branch in chemistry for dealing about the what are the things which are going to be affecting, what are the things which are going to be affecting on the speed of reaction, methods of measuring the speed of reaction, everything related to speed of the reaction is studied under one heading. That branch of chemistry is nothing but chemical kinetics. Okay, so here rate of reaction is denoted with R. R is equal to rate of change of concentration divided by change in concentration upon change in time. How much concentration is changed. Here in future also, whenever I write as a square bracket, you should understand that it is concentration. Change in concentration upon time taken for it. That is the rate of reaction. Okay. So this is what we are going to study. Understood? So in the numerator, it will be concentration. In the denominator, what it is going to be? Time. So ultimately what we are going to get is rate of the reaction. Okay. Now let us take a reaction, simple reaction. A moles of A react with B moles of B to form C moles of C and D moles of D. This is a reaction. Once reaction proceeds, there will be only two things happens. What are those two things happens? Reactant gets consumed and the product gets produced. Okay. So rate of reaction can be written in terms of the two values. Rate of reaction is equal to, first thing is rate of decrease. Rate of decrease in concentration of reactant. Okay, rate of reactants. First thing is rate of decrease in concentration of reactant. Otherwise, we can also say this is called as a rate of disappearance. What it is called as? Rate of disappearance. Disappearance. Okay, this is rate of disappearance. Same way we can also call it as a rate of increase. Rate of increase in, but here it will be concentration of, in place of the reactant, what it is going to be? Product. Rate of increase in concentration of product. Okay, what it is? Rate of disappearance. So rate of appearance. What it is called as rate of appearance. Okay. So one thing you should make sure that here it is increase. What you should remember, here it is increase and here it is decrease. So decrease is normally the sign convention, it will be negative. Increase will be sign convention, it is going to be positive. Okay. So that means when we deal with the product, when we deal with respect to product, it is better to use positive sign. When we deal with reactant, it is better to use, as it is a decrease, it is better to use what? Negative. Okay. So the rate of reaction in terms of the reactant is equal to rate of decrease in concentration of reactants. Concentration of what it is? Reactants. Okay. And it is also equal to rate of increase in concentration of product. Okay. So, but all the reactant may not react at the same speed. All product may not form at the same speed. What is that logic? I will tell you. Okay. So up to here, I think it is understood. Now let us see the units. Okay. And short representation. Units and short representation. R is equal to increase. That's why positive for product. Okay. Delta concentration of product. Product delta will be always in final minus initial and delta T. Okay. Some same way the reactant minus delta reactant. Okay. Reactants divided by delta T. So this is with respect to reactant. I told you in just now as a minus and product will be plus. Okay. Will you remember? Product plus memory technique. Okay. Product will be plus, reactant will be minus. Okay. Now let us see what will be the units. So in the unit side, in the numerator, what I told you, this is concentration. So concentration unit will be mole per liter. So we can write it as a mole liter inverse. And denominator, what it will be? Per second or per minute. Let us take per second. So mole liter inverse per second. Otherwise, mole liter inverse second inverse. What will be the units? Mole liter inverse and second inverse. So this will be the units. Now two different ways. When will be plus, when will be minus? What will be the units of rate? I think, is it understood now? It is clear? Okay. Let's see about the further topics. Okay. Okay, let us take this one. This reaction. I just now told you all reactant will not react the same way and all product will not react the same way. Because here in 1 second, suppose 1 mole of reactant is reacting. In the same time, how many mole it will react? 3 mole it will react. So at the same time, how many mole it will form? 2 mole of ammonia will form. That means the way it is reacting is not equal to this. The way it is reacting is not equal to this. So when somebody asks what is the rate of reaction, do we have any answer? No. So to make it average, what we should do per mole? What we will do per mole? This is the for 3 moles. So for 1 mole it will be 1 by 3. This is for 2 moles. Therefore it will be 1 by 2. This is already 1 mole. So you can take it as a 1 by 1 also. Understood? That's why when rate of reaction is taken as a uniform measurement for the entire reaction, it is better to divide this rate of disappearance for reactant or rate of appearance of the product with their coefficients. Is it understood? So for this rate of reaction is equal to reactant, it will be minus and minus 1 by 1. Minus what it is? 1 by 1 delta. Okay. And to change in concentration upon change in time. Is it understood? Same way here also minus reactant minus 3 coefficient will be divided. So delta H2 divided by delta T. Okay. Now for product, what is the product here? Plus, for product plus PP. Okay. So 1 by 2 into delta NH3 divided by delta T. Okay. So delta NH3 divided by delta T, like this. Is it understood? So how to write product plus reactant minus coefficient 1 by. Okay. Why we are making that logic also? I told you. If you know the reason, then it will be easy to understand and easy to memorize. Okay. So that's why normally I will give you logic everywhere. Okay. If your logic is clear, then you will have that satisfaction. Okay. Now let us see this reaction. Okay. So this reaction, rate of reaction can be determined many ways. How many? Four ways, because two reactant and two product. Okay. R is equal to reactant minus 1 by A, delta A divided by delta T minus 1 by B, delta B by delta T. Okay. Same way, plus product 1 by C, delta C by delta T, and it will be plus 1 by D, delta D by delta T. Okay. So these are the four different ways. These are the four different ways of writing the reaction. Number of ways we can write the reaction is equal to number of reactant and number of product. Okay. So if I don't write this, okay, so one thing I will tell you clearly, people are getting confusion and they are giving wrong answers. Okay, that should not happen with you. I will clearly give up to what is. Okay. Now suppose 1 upon A into delta A by delta T. Okay. So if I take only this part, which part? Only this part. Okay. With negative, then it is called as a rate of disappearance. Okay, of A. Now if I take complete one, if I take complete along with A, then it is called as a rate of reaction. Okay. Simply what we can say, when rate of disappearance divided by its coefficient, then you will get what? Rate of reaction. Okay. This total completely it is called as rate of reaction, and only this circle, this is called as a rate of disappearance. So like this you make diagram. This is memory diagrams, easily understandable. Unnecessary writing paragraph is a old fashion. With the diagram and animation is a new fashion. Okay. So is it understood? Any doubt about this? No doubt. Then one more thing also I wanted to tell you. Okay. What is that in terms of the product? Okay. So rate of R, if we write it as a product will be plus 1 by C delta C by delta T. Sometimes delta can be triangle, delta can be D also. So delta C by delta D. Okay. Now you can understand, if I write only this, not this C, okay, then it is called as rate of formation. Okay. What it is called as rate of formation. Sometimes they also call it as a rate of appearance. Understood? Now, if I take entire this along with 1 by C, then it is called as rate of reaction. I will write Rxn. Is it understandable? Okay, it is fashion. Like in remote also FWD. You understand that forward. Okay. Like that RxN means reaction. Okay. Up to here, is it understood? Now we can make a general idea. Okay. So let us take general idea as rate of reaction. Rate of reaction is equal to rate of reaction is equal to rate of disappearance. rate of disappearance divided by coefficient. Okay, suppose if I take this will be here. If I take this will be coefficient. Okay, and it will be minus because disappearance will include minus. Okay, so otherwise minus of minus will get cancelled. Ultimately, you should make sure that this always positive. Answer of the rate of speed can never be. Rate of reaction can never be zero. Minimum value zero. Okay, sorry, rate of reaction can never be negative. Minimum it can be zero. Okay, so same way here, rate of disappearance divided by coefficient. Then next is rate of appearance also you can take. Okay, rate of appearance divided by coefficient. Okay, divided by coefficient. Is it understood, students? So this is the general formula. Anywhere they gave this, use this formula. Anywhere they give, use this formula. Okay, they give sometimes this, you can't find out then by using this formula. Okay, so these are the units of rate of reaction and the methods, formulas for rate of reaction. Okay, theory part, is it understood? Now let's see some graphics, graphical part. Okay, now let us take this as a graph. Okay, so what will be the parameters on any axis? Any guess? No guess. Very bad. Okay, I will tell you, don't worry. Understood? I am with you. When you don't know, also I am with you. When you know everything, also I should be with you. Okay, it is depends on you. When you are successful in life, you should be proudly saying that I am because of my name. Okay, so but if you are failure, that I know definitely will take my name. Okay. Okay, now let us take this as a here. We will take time. On x-axis, what will be the parameter? It will be time. Okay. And on y-axis, it is going to be concentration. What station? Concentration. Okay, concentration. Okay, on y-axis. Now you can tell me this curve represents two, concentration of what? In any reaction, there are two people only. What are those two people? Reactant and product. Is it reactant or product? How? Good. So this is the reactant because in the starting it is maximum, it slowly decreases. So this is the concentration of reactants. Okay. So now how to find out the rate of reaction? Okay, the depending on the way you adopt, depending on the way you adopt the rate of method of finding rate of reaction. Rate of reactions are divided into two types. Okay, what is those two types? Average rate of reaction and instantaneous rate of reaction. Average rate of reaction and instantaneous rate of reaction. First we will study about the average. Slow and accurate value, okay, will be given by the average. So then what we will do, suppose at this point we will note down the concentration. This is the, so this is the time t1. Okay, what it is? Time t1. And what it is? Concentration c1. What it is? Concentration C1. Now this is time T2. Okay. And now what it is? Concentration C2. What it is? Concentration C2. So with this, we can find out the rate of reaction or not. In this time gap, okay, actually rate of reaction is not constant. It will change itself like you only. Okay, so when you join in any coaching institute or in any institute in the starting after passing the 10th, you are with full josh, you will complete one chapter in 2 to 3 days, but slowly you will not complete even a one page after some days. Okay, so same happens with the reaction also. Reaction rate is very much fast in the starting, and slowly it gets cooled down. Okay, and someday it will finish off also. If it is a non irreversible reaction, then only it will finish off. Okay, and first order reaction, that also we are going to study. There are certain reactions which can never be finished. They are first. Okay, first order reaction can never go completion. This is a objective question. Once you are first, who can finish you? Okay, that way you can remember. Nobody can finish first. First and finish are opposite words. Okay, so two reactions can never be completed. Reversible reaction can never go completion. First order reaction can never go completion. Why it is what it is? Already chemical equilibrium about reversible reaction I have explained. There is wonderful lecture, group of lectures will be there in my playlist about the reversible reaction. Go through it. Okay, go to my channel, there you will find out playlist and chemical equilibrium, ionic equilibrium, thermodynamics. All I made just the chapters which are feeling problem by the students. Okay, so now I am starting with the course also, so that every chapter should be explained. Now till now I was concentrating only on tough topics. Okay, but the way you responded, you people responded, I started making videos on all chapter with lecture wise and theory and question wise. Okay, so let us come back to this topic. R is equal to change in concentration, okay, divided by change in time. And as we are talking about the reactant, it is a formality, you should write minus. Okay, reactant minus product plus. So minus here, delta means final. What is final here? C2 minus C1 divided by T2 minus T1. So this is the rate of reaction. If you find like this type of reaction is called as a average rate of reaction. What it is called as? Average rate of reaction. Okay, it is called as average rate of reaction. Do you understand now? Good. Now we will feel that y minus, because see, small value minus big value, you will get minus of that will be multiplied with minus of this, so that you will get answer positive. Okay, so average rate of reaction, is it understood now? No doubt about this. Now some people don't have patience, everything they want instant, right now, right here they want. Okay, for them also chemistry will serve. For such people, they want that at this time, at this second, they will come and say, now, right now, I want the rate of reaction. Okay, they can't wait up to this much gap. Then what we will do, they will say, just wait, sir. So then we will make a tangent. We will make a tangent to the curve at this point touching. At what point of time they want, we will draw a curve. Okay, so then the slope of this line itself will give you the rate of reaction. The slope of the line to the tangent, the slope of the tangent at that point of time will only give you the rate of reaction. Is it understood? No doubt about this. See, here you can see how the rate of reaction is varying. Okay, so is this part clear? What is average rate of reaction and what is instantaneous rate of reaction? Instantaneous rate of reaction is at a particular point of time. Suppose it is, suppose 3 o'clock 5 minutes. At that point, if you want to tell, then that is instantaneous rate of reaction. What is the rate of reaction between 3 to 3:30? So this way. Okay, at 3 o'clock 5 minutes, this way. Instantaneous and average. Like somebody asks, what is your marks? Then you will say, sir, this week I got less marks, sir. Then they will ask, so what is your average? Then they will say, Acha, okay, 1 week you are not happy or you are not well, yeah, that chapter was difficult, that's why you got less marks. Okay, so average will give you the correct information, because life is a up and down. Someday you will be down, someday you will be up, but that up should come early and up should remain for a long time. Okay, so that's why if you ask me about which is better, average rate of reaction is better, because someday it was good, someday it will be low. So both will be giving you correct information. Here, suppose if you measure here, you will feel bad. Very bad, rate of reaction is very less because the line will be like this, slope will be less. When you measure it, you will be very happy like this, and you will be hoping that type of reaction at here also. Okay, so that instantaneous rate of reaction, starting slope is more, slowly slope is decreasing. Here slope is like this, slowly it will slope will be becoming zero. That means rate of reaction is zero. Okay, so instantaneous rate itself changes, but average does not change. Some people, what they will do, they will start the reaction and note down the time. They will wait up to the end of the reaction, note down the time, total quantity taken, time taken. That's all. That is the average rate of reaction. Okay, no doubt about this. Now let us see about the some factors influencing the rate of reaction. Graphical representation, now it is over. Okay, graphical representation part we have completed successfully. Now what we will be doing, we will be concentrating on the factors affecting rate of reaction. Okay, rate of reaction. Okay, first one is concentration. What is the first one? Concentration. Okay, second one is temperature. What temperature? Temperature. Okay, third one is nature of reactant. Nature of reactant. Okay, and fourth one is surface area. Okay, surface area, or sometimes it is called as a specific surface area. Okay, next one is presence of catalyst. Presence of catalyst. Okay, so in many books they will give many things, but don't worry about this. Okay, we are going as per the syllabus, as per the examination pattern question. Okay, somebody may misguide you, will give you 10 headings. Why there is 10 headings in NCERT? These much, even some are there in one line only. Okay, but that one line I am zooming in so that you should understand with high clarity. Okay, so factors affecting rate of reaction. First one is concentration. Very simple. If you take the concentrated reactants, rate of reaction will be high or low? Very good. The rate of reaction is normally high only. Good number of molecule, good number of collisions, good will be the rate of reaction. Okay. What is the second thing? Temperature. Normally, if you heat, molecule will move fast and then rate of reaction will be high. Nature of reactant, when the reactants are highly unstable, so they will react with each other fast. If they are very stable, then why they will react? You have to poke them. You will react like that. Okay, then they will start reacting. If they wanted to react also, if the molecules are big in size, then they cannot react. If they are small particle, powdered particle, then they will react fast. Okay, so if somebody want to move from here to here, then if they are heavy, then they will take time. Their rate of reaction will be slow. If two people are very thin and lean, okay, then they will go fast. That rate of reaction, powdered form. Actually, why powdered form? Because surface area, specific surface area is more. Okay, suppose if I take like this. Okay, now if I break this into this much pieces, then this can react fast than this one. Same particle, but broken into powder, because surface area has increased, surface area has increased, surface area has increased, surface area has increased. Okay, so that way surface area, specific surface area is more, than rate of reaction will be more. Okay, fifth point, what is the fifth point? Presence of catalyst. normally we will try to improve the rate of reaction. Okay, so if we use the positive catalyst, then rate of reaction will increase. Then if we use the negative catalyst, rate of reaction will decrease. So rate of reaction depends upon the type of catalyst used. Okay, sometimes in presence of catalyst also there are certain substances which are called as a promoter. Okay, so promoter will improve the catalytic property, catalyst will increase the rate of reaction. Okay, same way catalytic poison. Oh, they are all called as inhibitors. What they are called as? Inhibitors. What they are called as inhibitors. So they will decrease the activity of catalyst. Okay, so they will just decrease the activity, inhibitors. They will improve the activity, promoter. And whether it will improve the rate of reaction or not, that is called positive catalyst and negative catalyst. These are the factors affecting rate of reaction. We are going to study in depth every topic. It is just a introduction. Whatever thing you have studied now is only just an introduction. Okay, actual picture is going to be started. Okay, so I hope this introduction you understood well. If not understood, go through it again and try to maintain proper notes. And as a help or as a formality, you should inform to your one friend at least and ask him to subscribe my channel. Okay, so that he should also get the help and he should also improve the marks. Okay, bye bye, see you in the next lecture of chemical kinetics. Bye.